So let's get to, it's on one of the pages, it looks like multiple stepwise regression. Let's look at that first screen there. When we ran this, which variable was entered first for depression? Which one?
Emotional exhaustion.
Yeah, and it says the step was, it had to be significant, less than 0.5. It put in emotional exhaustion first. That was model number 1 on the first variables entered and removed. So that was put in. If you go down to the second screen with model 1, how much did you account for under adjusted R squared?
49.3%.
So if you know emotional exhaustion, you can account for 49% of the variability in depression. Is that amount significant in, whoops, I put emotional regulation article. Sorry, I didn't mean to. Cross that line out there. The ANOVA screen, when you put in with model 1, emotional exhaustion, is that significant?
Yes. Yes.
Yeah, it is. F1 in 40 equals 41, P less than 0.001. So we know emotional exhaustion accounts for a statistically significant 49% of the variance in depression. Was that it? Was it done? Did it add anything else in? Depersonalization, after emotional exhaustion was put in, also added into the equation here. And when you put depersonalization in, what happened to your adjusted R squared? It went from 49% to what?
60.
60. So adding a second variable added how much of accounting for the pie here?
11%.
11%, that's actually pretty good. And now when you have both of these, is that statistically significant?
Yes.
Yes. So that's good news.
Excuse me.
Let me show you a couple of other things on the screen here. I'm surprised I didn't put this in your output. Sorry about that. So these things were put in. There's a screen on the stepwise that is not in your handout called excluded variables. And look what happened with excluded variables. What was excluded?
Personal accomplishment.
Personal accomplishment was rubbed out because it was not part of the equation. Question? Nope. So personal accomplishment did not figure into the equation. It was not significant. So you really wouldn't want to do the enter method because that doesn't, as you said, weight in what's important and what isn't. I like the stepwise approach. The other very important thing is that when you choose predictor variables, let's say you were trying to, for example, I'm going to come back to the table here. Let's say you wanted to let's say you were trying to predict marital happiness. You think there are scales that measure marital happiness? Sure. And let's say that you you were looking at this from the wife's perspective, and you gave the wife a survey that measured both anxiety and depression. And you wanted to see if those two variables might predict marital happiness. Do you think both of those variables might figure into that?
Mm-hmm. Yeah.
Yeah, they could. But it would actually be a bad idea to do those two variables. Does anybody know why it would be a bad idea?
Because isn't there already some potential correlation between those two variables themselves?
Bingo. You want to choose predictor variables that take different pieces of the pie. If you look at the screen here, coefficient, what is it called? It's the collinearity statistic, that you don't want to have variables that are accounting for the same piece of the pie. Anxiety and depression would probably account for a lot of the same things. You want completely separate things.
Money.
Money,
And then,
SES.
and then pick either
Well,
anxiety or depression. Pick one
Yeah,
of those.
one or the
Throw
others.
it in.
But you want separate predictors. So with something like heart disease, you know, personality type, although the type A thing really hasn't been borne out over the years, personality type, exercise, nutrition, you'd want different predictor variables. You don't want predictor variables that overlap. That's considered
How do you,
it'll tell you that
okay.
when you run it.
So you could run it and realize, oh man, these two skills must overlap in some
Yeah.
way, even though I didn't expect it.
Even though you didn't expect it, and you know, anxiety and depression is just the simplest example I can think of, because all psychologists know that those two are very correlated with one another. So you really want, with regression, to predict things, different pieces of the pie here. That would be important.
That's good. I was gonna say, because I could see where you could be biased to believe that things were linked, when maybe they weren't, and maybe
Yeah,
you
and
skewed
then
yourself from the start in your study.
And then if you're measuring all sorts of things, it gets kind of tricky. That if you're measuring 10 different things and it's just kind of the garbage dump, you know, in statistics, and you've probably heard this, garbage in, garbage out. If you just measure all these things without any real model for how you're doing it, you might get something, but then what if these are overlapping with those? Which ones do you include, which ones you don't? If you don't have theoretical questions saying, I think these will do this and those will do that. The other thing that is sometimes done, so the last thing I wanted to kind of go over with you here was different types of regression examples. One of the other types that's often done is called hierarchical. And in hierarchical, you kind of cluster a couple of variables to go in step one, and then step two might cluster some other thing. That's called hierarchical.
So it's like stepwise, but with chunks rather than just one.
With a few things. That's called hierarchical. But the other question I wanted to ask you, with all of these examples I've been going over, how many, I've been dealing with one DV, that DV has been what? Continuous or categorical? Continuous. Let's take the heart attack example. Sometimes in healthcare we deal a lot with heart attack situations. Is that a very serious situation?
Yep.
Would we want to predict who's going to have a heart attack or who is not?
Yes.
So the variable of heart attack, what kind of variable is that?
That's either yes or no.
Yeah.
And so is that a continuous variable?
No.
No, that's a categorical variable. If your DV is categorical, the statistic that you choose, and I don't have an example here with me, you do a special type, speaking up because the recorder is over there. We can do it. Analyze, regression, linear. Let's see if we've got it. Not that one. It's called logistic regression. Logistic. It's called logistic regression. Logistic. It's called logistic regression. And in logistic regression, the DV is kind of one of two levels. Lots of times in colleges, do they want to know who's going to stay and who's not? Do colleges spend a lot of money recruiting people?
Yeah.
And would you want to have predictor variables that might predict
Yeah.
the old, what was that song, Rock the Casbah? Should I stay
So
or
it
should
would
I go?
be yes, they stay, and one they drop. You know.
So you would do a logistic regression there. It's almost like that's kind of a chi-square type of regression, because it's either yes or no, but it still kind of follows the same
then you
rules,
put
but
things
that's...
in like your high school GPA.
Yeah, you put in-
extracurricular activities.
So for heart attack,
Yeah.
it would be that way. So who had a heart attack and who didn't? The predictor variables could be continuous or categorical. Gender, age, dietary, exercise, personality type. But the DV is either you had it or you didn't. You dropped out or you didn't. And that's called logistic regression. That's a different type.
I don't think I ever understood the difference between those two.
Have you seen the term?
I've heard the terminology.
So in
But I don't think
logistic,
I ever knew the difference.
in logistic, that is what is actually run. So, let's see, did we get the results in this situation and kind of go over them? I think we kind of did.
Look at the kids.
Okay.
Thank you.
I was just going to cover one more thing on emotional dysregulation. And since you're leaving here, I guess she's being emotionally dysregulated. Thanks for doing that example. Thanks for being here. No, you're fine. You're good. Actually, let's just spend a couple of minutes on this and we can call it a day. In this particular article, I wanted to go over it. We actually covered this earlier on, but there was a part of this where they actually did some regression things here. Let's see if we can actually find that. Results.
Is it table 2
Table 2.
or table 3? Predictors. Is that what you want?
Yeah.
Table 3?
Table 3. Actually, Table 2 shows the correlations. And actually, let's start with Table 2 here. So they were trying to predict emotional dysregulation in autism. They had all these scales, right? A lot of scales. Notice the correlations here. And do they actually report one of them wrong? Look at the second one, adaptive behavior. What was the correlation there? In
0.02.
0.02. And what do they say, P?
0.89.
0.89. What should they have said?
Greater than.
0.05.
0.05.
So this is a peer-reviewed journal, and not only did the authors, but the editors didn't pick this up. I mean, these are some correlations here of some magnitude. So they have something here. And then we go to Table 3. Beta is kind of the way we look at things here. It's kind of part of the multiple regression. Notice right under multiple regression, they give the R squared, that's the adjusted R squared.
Oh.
Do you see that there with adjusted R squared equals 0.31?
Yeah.
So if you know restricted and repetitive behavior scale, you can predict emotional dysregulation. You can account for 31%. I'm not sure if it was just that one or all 7 of these or 8 of these. They have 7 for degrees of freedom, so it kind of makes me think that they had 8 scales in here. And it looks like they, actually, I think they probably just dumped all 8 in.
But the
and
only one that really
mattered
was restricted and repetitive behavior scale.
And I don't know if they did any stepwise situation here. Let me see. Oh, it looks like on the page under Table 2, in multiple regression analysis, the second column was used to test the core features that predicted emotional regulation, dysregulation best. They put in age, gender, this, that as predictors. Why they did that, but that's what they chose. When they put all these in, the coefficient of determination was 42%, and it was statistically significant. So that's okay. That's sometimes how you see it done. But does that, for the article reading part of the equation, does that make a little more sense?
Yeah.
They could have done a stepwise. Did they need to? Not necessarily. My preference is to do it that way, but it looks like they kind of said this was the only one that really mattered. It would have been interesting if they put that one in alone and gotten the R squared value. And if it was just 36%, then you might have just said, let's just use this one and not use all these other ones. They didn't give any rationale why they put all those other ones in. They just said, oh, we just put them in. So that's the way of it. So this article actually does okay with it. They've made a few minor mistakes, but oh, and in the very bottom, right before it says discussion, do you see where it has that little pyramid R squared change? says R squared
Yes.
equals 0.05. Do you remember before when I did the emotional exhaustion and then the depersonalization? Do you remember that when you had emotional exhaustion, you accounted for 49%? And when you added depersonalization, what did it go up to?
Increase it like
11%. That's the change in R squared.
Okay.
So if you add
But that's what they say right before that.
yeah,
in the sentence.
they kind of get to
The
that.
other variables are held constant and explains an additional 5% of the variance in emotional dysregulation above and beyond the other predictors, and then they give us that.
So why have the other 5? But you report it and you say it, but hopefully in their discussion, they really talk about this restricted and repetitive behavior scale kind of being the main driver of what's going to predict emotional dysregulation. There's nothing wrong with reporting these things statistically, but hopefully in their discussion. And actually, if you look at the table 3, right under that, restricted and repetitive behaviors appear to be the best predictors. So they get it.
So is beta a different term for something we've been talking about?
Beta is very much related to the coefficient of determination. Sometimes people use beta as the primary indicator. In the screens that we've been looking at, they do show a beta value, and sometimes people use that.
Okay.
So yes, the answer is yes to that. Let me actually just run it one more time, and you'll see it actually come up here. Adjusted R squared. Yeah, it's the standardized beta values. Do you see it here on the screen? Some people, I know, for a statistician, psychologists are very good at t-tests, ANOVAs, chi-squares, and those things. Psychologists know, and I know, a lot about regression as a psychologist. Statisticians know a lot more. I've had huge books on multiple regression that are hundreds of pages long. Beta values are sometimes important. If you notice here, they are large here, and sometimes that's what's reported, and that's perfectly fine in these situations. So, in summary, hopefully what you've learned in these, actually let me